Okay, this is something we locked in first week of class, and y'all have been doing real well with it. And you're pretty much doing okay with it now, but I saw a few little glitches. So you have a over x plus 3. What are you going to do with that?
Multiply the top and the bottom by x minus 2
Why?
to get you the same denominator.
Yeah, you got to get the same denominator, and it's going to have to have an x plus 3 in it. It's going to have to have an x minus 2 in it, right? So you have to understand that rather than like doing this by habit. Otherwise, you might do x plus 3 over x plus 3, which wouldn't give you the same denominator, right? Or x minus 3 over x minus 3, which is a lot like what you do if you're dividing complex numbers, okay? So you have to understand what you're doing and why you're doing it in order to avoid little mistakes, okay? So that's x minus 2 over x minus 2. Then it's going to be plus b over x minus 2 times x plus 3 over x plus 3. And it's very easy. So you get ax minus 2 plus bx, ax minus 2a plus bx plus 3a. And I'm skipping steps here that you shouldn't skip. Okay? Show me the steps for your own sake. Okay, so that becomes ax plus bx, put like terms together, minus 2a plus 3b, this should be a b here, over x plus 3 times x minus 2. Now, we're going to factor the x out here. Using the distributive law in reverse, we're going to say that's a plus b times x minus 2a plus 3b, all that divided by x plus 3 times x minus 2. Okay? And the rest of this is just straightforward stuff. You haven't done it with symbols like A and B, but it's just what you already know how to do. Everybody think they're okay with that? I think you will, and I think you are. Okay, so if you made a little mistake, make sure you think about what you're doing and why, so you don't make little mistakes. That way you can save your energy to make big mistakes. No, we don't want you to do that. Okay, now, let's suppose that we have the expression x plus 3 times x minus 2. Noting that x plus 3 and x minus 2 are the same things we had over here. Okay? I'm telling you that you can, well, you see that when we add something over x plus 3 to something over x minus 2, we get something over x plus 3 times x minus 2, right? And that something can have an x in it and can have just plain old numbers, because that's what these are going to be if you know what a and b are, right? If a and b are just numbers, you just have a multiple of x and then a number on top, right? Okay? Well, that's exactly what you have here, isn't it? You have a multiple of x and some number on top, right? Over x plus 3 times x minus 2. So we're going to say, okay, we see this. We don't know this. But when we see this, we say, okay, well, geez, I know that I can write this as a over x plus 3 plus b over x minus 2. Okay? And there are good reasons you want to do that. If you take any kind of a calculus course that has a little integration in it, you have this thing called partial fractions. Turns out you can integrate this very easy. You get natural logs. You can't integrate that easily. So there's something you do in calculus It's much easier to do with this than it is with this. And there are other reasons you might want to do this, okay? So, for many good reasons, this is called partial fractions. Now I'm going to ask you to do one of these, or actually maybe a couple for homework. So, because of what we did over here, we could go through the whole process. So 2x minus 7 over x plus 3 times x minus 2 equals a plus b times x plus, I'll put parentheses around it. Now over here I had negative 2a plus 3b, but I wrote it as 3b minus 2a and put parentheses around it. So that's the only difference between what I have here and what I have down here. So there we have it. Now what good does this do us? Anybody see how this could possibly do us any good? Well, that's a stretch. Anybody have any glimmers of insight? Probably not, unless you've seen it before. But where we're leading with this. Okay, well, what's in front of x over here?
2.
Good. Yeah, they're on top of it. What's in front of x over here? So what's a plus b have to equal?
2.
Yeah. And what do you think 3b minus 2a is going to have to equal? Negative 7, right? Okay. That makes sense? Well, now you have two simultaneous equations in a and b. We solve it for a and b, right? So we solve for a and b. Now I would put my b here and my a here. So I'm going to rewrite this. A plus b equals 2, negative 2a plus 3b equals negative 7. Okay? If I double the first equation and add them, the a's go away. We end up with 5b equals negative 3. B equals negative 3/5. I'm doing this quickly because you can do this. Yeah, y'all have been good at this for a while. Okay? So B is negative 3/5. We plug that in here. And out of that we get A minus 3/5 equals 2. So A equals 2 plus 3/5, which is 13/5. It follows then I'll say thus, just to be pretentious, 2x minus 7 over x plus 3 times x minus 2 equals 2 over x plus 3 plus negative 3/5 over x minus 2. And then I'll say et cetera. This is a complex fraction, you want to simplify it. But there it is, okay? Now, what do you do once you have this? Well, if you're in a calculus course, you integrate it, and it turns out it's really easy where you had no clue in this one, but you're not in a calculus course. But what do you do no matter what course you're in? You check your solution. How do you check your solution? You add these and see if you don't end up with this. Okay? You can do this addition just as well as you can do that one. Okay? You know how to do it, so do it. Make sure you get what you started with. Okay?